Here we are going to learn how to perform calculations using log table. Before going ahead, we'll look at the basics. So it will be easy. First important thing that you have to remember is like, plus and minus, multiply and divide, log and antilog. What I mean by this statement is, suppose if you take an equation x equal to 2, okay, now if you add and subtract a number from this equation, for example, this is the equation, we add 3 and subtract 3 from this equation, the equation remains unchanged. Okay, the equation remains unchanged, x equal to 2, right? Similarly, if we multiply and divide a number to an equation, the equation remains same provided that number is not equal to 0. Similarly, if we take antilog and log of a number, okay, we'll get the same number. Both will get cancelled, like in the case of plus and minus and multiply and divide. Okay, so what I mean by that is, if a number is 2, okay, then antilog of log of 2 will be equal to 2, because antilog and log can get cancelled, right? Second thing that you have to remember is law of logs. That is, first law is log of a into b is equal to log a plus log b. Second thing that you have to remember is log of a by b is equal to log a minus log b. A general thing that you have to remember is, anything that is in the numerator, log will be added, and anything that is in the denominator, log of that number will be subtracted, right? Since b is in the denominator, we are subtracting log of b, and since a is in the numerator, log of a is added. It has a plus sign over here, right? And third thing that you have to remember is log of a raised to n is equal to n log of a, right? This is all about the laws of logarithm. Third thing that we will do is, before going into the detailed calculation, we'll study how to find log of a number from log tables, right? What I mean by log is log to the base 10. Okay, so let us take an example of a number 15.42. okay, now if we have to find log to the base 10 of this number, we have to remember two things. It is summation of characteristic and plus mantissa. Okay, log of any number is a summation of characteristic part and mantissa part. Okay, now both of these things is easy. First part, that is characteristic, you can find without using any log table. And characteristic is given by number of digits number of digits before decimal place minus 1. Okay, in this case we have two digits, that is 1 5 15. So in this case characteristic will be 2 minus 1, that is equal to 1, right? Now second part, that is mantissa, you can find from log table. Okay, now before going to that, before going to log table, we'll first see the number, right? The number of which mantissa we have to find is 1542. 1542. Here you have to ignore any decimal point, right? So the number that we'll get that we have is 1542. Though the actual number is 15.42, we'll use 1542. The first two digits, this gives row number. Third digit gives column number, and the fourth digit gives mean difference. So the row number here will go to row number 15, column number 4, and mean difference 2. We'll go to row number 15, column number 4, and mean difference 2. Now let us go to the log table. Okay, we'll go to row number 15, column number 4, 1875. We get a number of 1875, right? And the mean difference 2. In the same row 15, mean difference 1542, that is 6. This is the mean difference, means the mean difference 6. Okay, now mean difference, it has to be added to this number, so the final number becomes 1881, right? 1881. This is the number that we'll get from 1881. The final number that we'll get is 1881. Now this is not the actual mantissa. Mantissa is, you have to place a decimal point before all this number, that is 0.1881. Mantissa of a number, of any number that you will get from log table, should be greater than 0 and less than 1. The mantissa of this part is 0.1881. Okay, so the log of 15.42 is equal to sum of characteristic and mantissa, that is equal. Our characteristic is number of digits before decimal place minus 1, that is number of digits before decimal place is 2 minus 1 plus mantissa. Mantissa is 0.1881. Log is 1.1881. Okay, this is 1. Okay, now let us take a second example. Second example is log of 836.1. As we have already seen, it can be divided into two parts. First part is characteristic and second part is mantissa. Characteristic is given by number of number of digits before decimal place, right? Here we have 3 digits, 836. So characteristic will be number of digits before decimal place, that is 3 minus 1. We have to subtract 1. Okay, so characteristic will become 2. And mantissa, for finding mantissa, the 4 digit that we have to look in log table is 836.1. Okay, but in mantissa we are ignoring any decimal places, so in log table we'll find 8361. Okay, the first 2 digits is row number, third digit is column number, and the last digit is mean difference, right? So row number is 83, column number is 6, and mean difference is 1. Now let us look at a log table. We'll go to row number 83, column number 6, 0, 1, 2, 3, 4, 5, 6. This is column number 6. The number that we'll get is 9222, right? 222, and the mean difference in column number 1 we'll get a mean difference in the same row 83. Mean difference 1 is 1 plus 1. Okay, so final number is 9222 plus 1, that is equal to 9223. Okay, this is a number that we'll get from log table, but the actual mantissa part is, find the actual mantissa part, you have to place a decimal point before all this digit. Mantissa is equal to 0.9223, right? So the actual value of log 836.1 is equal to characteristic plus mantissa, that is equal to 2 plus 0.9223, that is equal to 2.9223, right? Let us take a third example of to find log of 0.235. Again it will have two parts, characteristic and mantissa. To find characteristic, we will subtract 1 from the number of digits before decimal place. Though is insignificant, we can write it as 0.235. So the number of digits before decimal point in this place is 0, and we have to subtract 1, that is minus 1. Characteristic of this number will be minus 1. To find mantissa part, we'll take only significant digit, that is 235. 0 is not a significant, right, as we have already discussed. So in log table we'll find 235, right? So as we have already seen, first 2 digit is row number, first 2 digits, here it is 23, column number, third digit, that is 5, and fourth digit mean difference. Here since we don't have any 4 digit, we will not look at any mean difference, right? So we'll go and look in row number 23 and column number 5. row number 23 and column number 5. 3711. Okay, so the number that we'll get from log table is 3711. So Mantisa will be 0.3711. Now to find the log of 0.235 is equal to -1, that is characteristic, plus 0.3711. This is Mantisa. Write this as -0.6289. This is mathematically correct, but since we have to find antilog of this value, an antilog table, general antilog table available doesn't give an antilog of negative number. So what we have to do is we have to write a number that is before decimal place, that can be positive or negative, but a number after decimal place has to be positive. So our value, that is -1 plus 0.3711, this can be written as bar 1. Bar indicates negative, and 0.3711, this is positive value. Okay, so in this format you have to write this value. So so log of 0.235 is given by bar 1.3711. You have to remember that bar 1 means it is -1 and 0.3711 is plus 0.3711. Okay, we are done with finding log of a value. Now we'll look at how to find anti-log from log. Basically it is anti-log table. In log table generally we will find anti-log also. Okay, now we are going to find anti-log of the log values that we have already found out. In first example we got a value of log as 1.1881. Okay, now we already know that this value consists of two part, characteristic and Mantisa. Now here characteristic value is equal to 1 and Mantisa part is 0.188. Like log also consists of two parts. The first part is given by the characteristic and second part is given by Mantisa part. Right? In this part what you have to do is you have to take 10 to the power of a characteristic value. In this case characteristic value is 1, so antilog will be 10 raised to 1. Now suppose it would have been 2, then the antilog will be 10 raised to 2. Right? For any general characteristic value of x, antilog will be 10 raised to x. Right? Mantisa part is 0.1881. Now this value we have to look in antilog tables. Okay, let us move to antilog tables and we have to search for 0.18. Same logic, first two digit 0.18, this gives row number, third digit column number, and fourth digit mean difference. So we'll go to row number 0.18, that is this row number 0.18, column number 8, that is 1542, right? And mean difference is 1. In first mean difference mean difference, we'll get value of 0. Generally you have to add the value that you get from row and column number with mean difference. Mean difference has to be added. So total value is 1542, right? 1542. Now this is not the actual Mantissa part. Mantissa will be 1.542. You have to place a decimal point after first digit. Okay, first digit from the left. So 1.542. So the actual value of antilog is 1.811 is equal to product of characteristic part into Mantissa. Characteristic part is 10 raised to 1 into Mantissa part is 1.542. So that is equal to 15.42. This is the actual value, if you remember, right? 150 or 15.42. Second example that we'll take is suppose we have to find antilog of 2.9223. Again, it has to be divided into two parts: characteristic and Mantissa. Here the characteristic value is 2, so the value of antilog will be 10 raised to 2, and Mantissa part is 0.9223. So row number 0.92, that is given the first two digits. Column number is 2, and mean difference is 3. So from this two value we'll get is 0.92 and column number 3. This corresponds to column number 0, 1 and 2 and 3. Okay, the value will be 8375. Okay, 92 and third one 8375 plus mean difference in third 1 2 3, that is equal to 6. Okay, the final value is 8381. Okay, this value is 92 and second column, 92 zeroth column, first column, second column. This is second, right? 92 and second is 8356. This value is actually 8356, and in this the third main difference is 6 plus 6, that is equal to 8361. Okay, and the actual Mantissa part will be put a decimal place after first digit on the left. Okay, so it is equal to 8.361. Okay, that is equal to 8.361. So final value of antilog of 2.9223 is product of Mantissa and characteristic, that is equal to 8.361 into 10 raised to 2, that is 836.1. Let us take a third example. In our last example, antilog, we will find antilog of bar 1.3711. Again, it has the same procedure. Antilog is divided into two parts: characteristic and Mantissa. In this place, characteristic our characteristic part is bar 1 or minus 1, and the antilog will be 10 raised to minus 1. Okay, mantissa part is plus 0.3711. So antilog of this value, for antilog of this value we have to look in log tables. If you remember, bar 1 0.3711 corresponds to minus 1. This value is bar 1, bar indicates negative, minus 1, and the value after decimal places, that is 0.3711, were positive. 0.371 were positive, and this value is negative. Right? To find the mantissa part of 0.3711, you have to go and look in log table, antilog table, in row number 0.37, column number 1 is, in this case it is 2350, and mean difference is 0.37, row number, column number 1, and mean difference as 1. Okay, this is mean difference. Okay, so this value will get as 2350, right? 0.37 and column number 1, and mean difference, first column number 1 will get is 1, value is 1 plus 1, that is equal to 2351. So the actual value of mantissa part, as we already discussed, is 2.351. So mantissa part is equal to 2.351. Now, after finding characteristic in mantissa, antilog of characteristic and antilog of mantissa, the final value can be written as antilog of bar 1.3711 is equal to product of mantissa, that is 2.351 into 10 raised to minus 1. This gives a value of 0.251, right? 2351. Okay, so till now we have looked, we know how to find log and antilog from log tables. Okay, now by using log tables, let us find a value of r, that is given by root of 2 into 9.8 divided by 3.142 into 2.4 into 10 raised to 8. Right? As we already discussed, that log and antilog are opposite, so antilog of log of root 2 into 9.8 divided by 3.142 into 2.4 into 10 raised to 8 will give the same value. Okay, so now we'll expand. As we know from the 3 rules of logarithmic, you can write this value as log of 2 into 9.8 divided by 3.142. raised to 1 by 2, that is equal to antilog of half log of 2 into 9.8 that is equal to antilog of log of 2 plus log of 9.8, anything that is in the numerator log values of that number, right? And anything in the denominator, this sign outside log will be minus log of 3.142 minus log of 2.4 minus log of 10 raised to 8, right? Minus log of 10 raised to 8. So value will become half log 2 plus log 9.8 minus log 3.142 minus log 2.4 minus 8 log 10. So after substituting appropriate value from the table, we will get value as log of 2 will be 0.3010 plus log of 9.8 is 0.9912 minus log of 3.14 is 0.4972 minus log of 2.4 is 0.3802 minus 10 minus 8. Till it is 8. Log of 1 is 10 is 1. After doing appropriate calculation, we will get antilog of minus 3.7926. Okay, since if we expand this value, minus 3 minus 0.7926, as we already know, we cannot get antilog of negative number, so we have to make this value as positive. So one trick that you can remember is you can add and subtract 1, right? Minus 0.37, you can add and subtract 1, that is minus 3 minus 1 plus 1, this we can do mathematically, it is correct, minus 0.7926. Now this value gives you minus 4 and this value gives you plus 0.2074, that is, and this whole term can be written as antilog of bar 4.2074, and antilog of this value will come as 1.612 into 10 raised to minus 4, right?